there is no friction occurring at this point here. In part A, we've got to show that the normal contact force between the ladder and the wall is equal to mg a plus 2d in brackets times by root 3 all divided by 4h, and this will give you 4 marks in the exam. Once you've done that, you're going to be able to use this answer, and you now know the question is in equilibrium. So we've got limiting equilibrium, and the coefficient of friction between the ladder and the ground is root 3 over 8. So using this information here, as soon as it's mentioned in limiting equilibrium, you should be thinking of your formula involving friction and the coefficient of friction and your normal reaction force. And then you've got to use that information to show that H is equal to K times by A plus 2D, and you've got to work out the value of K, and this is going to be worth 7 marks. Part C, you've then got to work out in terms of A the greatest possible value of D for 2 marks, and the last part is an improvement that could be made for 1 mark. Now this question here is got a lot of marks. The last one here is an easy mark, so even if you can't do the earlier parts, you should be able to get the last part of this question regardless. The next part, part B, relies on part A, but the answer has been given in part A, so even if you can't do part A, you could still carry on to do part B. And similarly on part C, you are given, if you use the equation that you've given in part B, then you should be able to do part C. But this part here uses a bit of common sense. Now, to answer any questions involving moments, your key facts are that your moment is equal to your perpendicular force times by your distance, or your force times your perpendicular distance. I prefer to use perpendicular force times by distance, so this is the one I'm going to be using in the question. Some people prefer to work it out by doing your force times your perpendicular distance. You get the same answer. It doesn't matter which way you prefer to do it. It's personal preference. You also need to know that your clockwise moments will equal your anti-clockwise moments because we are in equilibrium. So we're in a balanced situation here. This ladder isn't flying away, it's not moving, it's staying balanced against the wall. You also need to know that your forces up are equal to your forces down when you resolve, and your forces left equal your forces right. And the formula linking friction and your normal contact force is friction is equal to mu times by R, and that's going to be useful in part B. So to start with, on any question, you must put your diagram forces on. So draw out the diagram, get your forces labelled onto this diagram, work out where all the forces are, and then see if you can have a go at answering the question. So press pause while you draw out this diagram, add on all the forces, and then press play when you're ready to hear the answer. Great work, guys. So hopefully you've had a chance to draw out the diagram and add your forces on. So it is very tricky to add your forces on because you need to make sure you've got the correct number of forces. So we've got this mass here acting at the centre. So we have got our first force coming down here at mg, and this is at an angle of 30 degrees to the perpendicular. So you've got a right angle triangle here. This is 30 degrees down here. You've got a right angle appearing here. So this angle at the top would be 60, which means this angle in here is 30 because you've got a right angle between here. Some people find it difficult to work out that angle. It is always the same as this angle here, and I've just explained why it is 30. So this is where my centre of mass is coming down here at mg. We've also got a mass of 2m added at point C. So that is going to be coming down here at point C. Just remembering your centre of mass is going to be half the distance from the top to the bottom. So the total distance was 2a, so this is going to be a distance of a. I've got 2mg coming down here. Again, the angle this is acting at will be at an angle of 30 to the perpendicular. So just bear that in mind. It's a little bit difficult to draw it on my diagram because it makes it a little bit cramped. So it's the same scenario as here. I've just drawn it as the 2mg coming down. Next, we've got our reaction force acting up at the wall. Now, this is the trickiest one to find. So you've got a normal reaction force. Now, this normal reaction force always acts perpendicular to the surface. Now the ladder is my surface. Okay, so this is my ladder. So where it is acting, where the wall, between the wall and the ladder, we've got a right angle. So here's my ladder, here's my wall, here's my normal reaction force, and the wall is under here. So this is the trickiest one here to work out which direction this normal reaction force is acting. It always acts perpendicular to the surface, and the surface is the ladder. So perpendicular to the ladder, at the point where it touches the ladder here, or touches the wall, this is where your RB force is acting. Then at point A, we were told that it is a object that is rough, which means there's going to be friction acting here. Now you need to make sure you get friction acting in the right direction. So imagine if this ladder, which is placed here, slips down. So if the ladder slips, the base of the ladder moves away from the wall, and as the base of the ladder moves away from the wall, the friction acts the opposite direction, so the friction acts in. The normal reaction force is nice and easy, that goes up, and the friction comes in here. So we've got a normal reaction force acting up here, I've got a friction acting across to the right, I've got a 2 mg acting down here at C, the centre of mass acting at mg in the middle, my normal reaction force here at point B, at the wall here, is at 30. I have called it B, even though it's not quite at the end, just because it's at this end of the line, and this one over here I've just called RA. You can use different letters, and the mark scheme does use RG for the ground and RW for the wall. It doesn't really matter what letters you use. So we're now in a position to work out my normal contact force between the ladder and the wall. Now over here we've got some formulas. So you're either going to be taking moments about a point, or you're going to be resolving up and down. Now part A and part B, one of them you're going to be taking moments, and the other one you're going to be resolving up and down and left and right. So we're first of all going to look at the normal contact force. So when we're looking at the normal contact force, because we only want the normal contact force acting here, at this point here, we're actually going to take moments. Now the reason we're taking moments is because if we act forces up and forces down, you've got an RA and an RB involved in this, and I don't need an RA in this question here. I want to get rid of this RA because I'm just looking to work out the value of RB in part A. So I only want to know this value here. So to eliminate this RA here, I'm going to take moments about this point here, A. So taking moments about point A is how we're going to get the answer to part A out. So I've chosen A because there are two forces at A that I do not know. So if I take the moments about A, it eliminates both of those forces. We're going to use the top formula here, the perpendicular force times the distance. So if I go clockwise, so the way the clock goes round, I've got two forces going clockwise. This pink one here, the 2 mg, and the green one here, the mg. So my 2 mg is acting at an angle of 30 degrees. So my perpendicular force is going to be 2 mg. My angle here is 30 degrees. Now I've got a little right angle triangle that has been formed here. Now this is the angle in between here. I'll just show you on the mg one because you can see it a little bit clearer. It works exactly the same for the 2 mg as it does for the mg. So you've got a line here forming a right angle triangle. Now of this right angle triangle, this side here is called the adjacent. This one over here is called the opposite. Now when you're using a formula using the adjacent, it's always going to be cos. If it's using the opposite, it's always going to be sine. So this side here is going to be mg cos 30 because this is the adjacent. Same in this scenario here. I've got this 30-degree angle here. So I've got 2 mg is going to be cos because it's the adjacent, and of the angle which is going to be 30. So that's my first force, my perpendicular force times by the distance, which is just going to be d. My second force going clockwise is going to be this one here, which is going to be my perpendicular force, which is going to be mg cos 30 again, times by my distance, which is a, and that will equal my perpendicular force, which is just going to be rb, times the distance from here to here, which is going to be L. So I'm going to call this distance here L, because otherwise I can't find the moments. So when I take moments about part A, we end up with 2mg cos 30 times by D plus mg cos 30 times by A is going to equal RB times by L. So we need to work out this distance from the bottom, from A, up to the top of the wall. Now you'll see here I've actually got a right angled triangle. So this is just a normal trigonometry question. Don't be put off by all the other forces on here. You can draw the diagram out again if it helps you. But this is going to be my opposite. This is going to be my hypotenuse. This is the angle 30. And I want to work out my opposite, which is the distance h. So using SOHCAHTOA, if I've got my opposite and hypotenuse, that is sine of the angle. So sine of the angle tells me is the opposite divided by the hypotenuse. So my opposite is h divided by my hypotenuse, which is L. So sine 30 equals h divided by L. You should know that sine 30 is equal to a half, or you can type it in your calculator to get the answer. So to work out the value of L, I'm just going to cross multiply, bring the L up, divide by the half, which means that L will equal 2h, which will give you your first mark for this question. Your second mark. Your first mark is for working out your moments. So second mark for working out the value of L. Your first mark is for working out your moments. To be honest, it doesn't matter the order you do these two steps in. Now L is equal to 2h. So I can replace the L here with 2h. So I've got 2mg cos 30. Again, type it in your calculator, or just know that cos 30 is root 3 divided by 2 times by D plus mg root 3 over 2 lots of A is equal to R times by 2h for your third mark. From here, I've got to rearrange to find RB, which is the contact force between the ladder and the wall. So I'm trying to work out RB. So basically, I need to divide everything by 2h, which will give me the value of RB. But it's got to be written in this form here. So you can see I've got an mg as a factor and I've got a root 3 as a factor. So I'm going to take out mg root 3 at the front, leaving me with a d and a over 2. And I've just multiplied both sides by 2. So I've just taken the factor of the 2 divided by the half, just cancels out, leave me with the root 3 mg times by d. And then I've got the mg root 3 over 2. So the root 3 is out the front, the mg is at the front, the 2's still inside here, so it's the half. So I've got a over 2 inside the bracket. And the 2h RB is on the right hand side. Now I need to rearrange this to get RB, so I just need to divide both sides by 2h. But if you look here, I've got a 4h in the denominator, so I actually need to take another factor of a half out the front here. Remember, when you take the factor of a half out, this d term becomes 2d, because 2d times a half gives me the 1d. So I'm now just going to divide by 2h to give me the value of RB. So that is root 3 mg over 4h times by 2d plus a is the value of RB, which is what is told here in the question, just written in a slightly different form. As long as your answer comes down to the same form or an equivalent form, you will get the marks in the exam. So this is where the fourth mark is awarded. The mark scheme on this question shows B1 is a method mark, M1 is a method mark. So for working out the distance along the ladder is your first method mark, M1 for taking a method mark for doing the moments, your answer mark for coming down to the correct answer with using the moments, and your fourth answer mark for coming down to this final answer, which was a show that. The AG just means that it was a show that question, so the examiner knows that you must show all your working out in order to be able to get the full 4 marks for this question. Now in part B, this is the really long question. This is the big mark question. And we know that we've got to show that H is equal to K times by A plus 2D. You're told in the question here that mu, because the coefficient of friction, is equal to √3/8, which means we're going to be using friction is equal to mu r. Now we've taken moments in part A, so the only two formulas we've got left to do are forces up equal forces down and forces left equal forces right. And if we do these two things, that means we'll be able to substitute these two into this formula here in order to be able to use friction equals mu r, and then that will be able to simplify into this expression here. Press pause, have a go at working out the answer if you haven't done already, and then press play when you're ready to hear the answer. Fantastic work, guys. Hopefully you've managed to show that H is equal to some value of K times by A plus 2D, and you must state this value of K to be able to get the 7 marks for this in the exam. So to start with, we're going to look at resolving up and down. So going up, I've got RA going up, nice and easy. Going down, 2mg and mg, again, nice and easy. The one going to the right, the friction, we can just ignore. So the one that's more tricky is this RB force up here. So I need to know what component of RB is acting up. So again, I've got a right angle triangle I can draw in here. This is the adjacent side. So when we use the adjacent, we're using cos. So this is going to be RB cos 30. So when I resolve up, I've got RA plus RB cos 30 is equal to 2mg plus mg. Cos 30 is √3/2. 2mg plus 1mg is just 3mg, and I can take this to the other side. So I've got RA is equal to 3mg minus √3/2 RB. So we've got 2 marks already just for resolving vertically. 2 easy marks. Now we're going to resolve horizontally. So going horizontally, friction is acting to the right. RA doesn't act horizontally at all, neither does this one or the mg. So the only other one that acts horizontally is this component of this RB acting across here, across the top. So we had here the adjacent. When we go across the top, we've got the opposite. When we use the opposite, we're using sine. So this is going to be RB sine 30. So all I've got to say is my friction is equal to RB sine 30 for your 3rd mark. You should know that sine 30 is a half, so you can write friction is RB over 2 for your 4th mark. So 4 easy marks to start with. From here, we've got to look at friction is equal to mu r. We know what r is, we know what friction is, so we can replace friction with RB over 2 times by mu is equal to mu times by my value of RA, which is 3mg minus √3/2 times by RB. Now we do know the value of RB in part A, and we will have to substitute that in. But if you substitute it in too early, it makes your calculation really tricky. So it is easier to keep RB in terms of RB at this stage here, put RB onto the same side, and once you've only got one term involving RB, then substitute this in, because if you go too early, it just gets really, really complicated. We're going to substitute mu to be √3/8, and this is your 5th mark. From here, I'm just going to do a little bit of rearranging. So I'm just going to multiply everything by 8. So 8 divided by 2 is going to be 4. So I've got 4RB on the left, and multiplying the 2 terms here on the right by √3, I've just got 3 √3mg, and then √3 times √3 is 3. So I've got 3/2 RB. I'm now going to combine these two RB terms. So I've got 4RB, and then I'm going to get rid of this minus 3/2 RB, which is the same as minus 1.5 RB. So I'm going to add 1.5 or add 3/2 RB to both sides, which is going to give me 5.5, which is the same as 11/2 lots of RB, and that's going to equal to 3 √3 over times by mg. Now we know the value of RB, which we worked out in part A. So even if you can't do part A, you can still use this answer in part A to be able to help you to do part B. So RB is the same as root 3 mg over 4h times by 2d plus a. Now from here you should spot that you've got a root 3 on both sides, so the root 3's will cancel on both sides. You've got an m on both sides, so these will just both cancel, and the g will cancel on both sides. So at this stage here, you've got another mark. We can do lots of cancelling here. You've got 11 in the numerator. You've got a 2 times by 4, which is 8. We're going to have to divide by this 3 on this side. So 8 times by 3 is 24. We want to get h on its own because the question says show h. So I'm going to multiply both sides by h. So that leaves me with h being 11 over 24 times by 2d plus a. The question says show that h is equal to k times by a plus 2d. So my value of k is this constant at the front, which is 11 over 24. And you must state that k is equal to 11 over 24 for your last and 7th mark. So this was 7 marks in the exam. It was fairly straightforward. There were lots of easy marks just for finding forces up equal forces down, forces left equal forces right. But if you haven't got the forces on your diagram drawn out correctly, then you're going to lose marks. So it is really important that you draw your diagram out carefully and you label up what you're trying to find and show all your working. Give yourself a big tick if you got that correct. Great work, well done. The mark scheme on this question shows you've got M1, which is a method mark. The star means it is just dependent on previous answers, so you can get method marks even if you make mistakes. So you are allowed sign errors or sign or cause confusion. OE means or equivalent. A1 is an answer mark, so you must come down to this form here, or equivalent, for your answer mark. M1 is another method mark for resolving horizontally. A1 is an answer mark for coming down to this stage here. OE means or equivalent. For using friction equals mu r, you get a method mark, so depending on these two answers here, you can get a method mark at this stage here. Then rearranging and solving will give you your 7th mark. So you get 2 answer marks at this stage here. We did it slightly differently and we combined these RW terms. In this case, we called them RB, but we combine them first before substituting. I think that's personally much easier than doing it the way the mark scheme's done it, because otherwise it gets really complicated multiplying all this out and simplifying. Give yourself a big tick if you got it correct. Well done. Now in part C, we've got to find in terms of A the greatest possible value of D. So this question is really tricky and quite confusing to work out what is going on for 2 marks. And most students in the exam did not get the 2 marks for this. It is very tricky to understand what is going on and how you get an equation in terms of D and A. Now, often when you're looking for greatest possible values, you're looking for a range of values. You're looking at using friction and mu r and an inequality involving this. But that's not the case in here. It's a bit more common sense. So it's harder to teach because you've literally got to use your common sense to work out, well, what is a suitable scenario for what is going on here to be able to solve this. So have a think about where the wall is in this diagram and what is the maximum scenario for where this h value is, which will then help us create an inequality in terms of A and D. Now the reason I'm saying that is because h is in terms of A and D, so we're going to look at a maximum value for h. So have a little think about it. What is the maximum value of h? Where will that occur and why is it the maximum? And then once you've got that, see if you can get an inequality using this answer here in part B, then create an equation in terms of D and A. Okay, great work everyone. Hopefully you've managed to come up with a formula. It is very tricky, and as I said, it is common sense working out what is going on. So we want to work out the maximum height. So the wall and the ladder to be in equilibrium, the maximum height here is going to be right at the end, because at the end of this diagram here, if the wall was any further away from the ladder would just be on the floor, it wouldn't be there. And if I come to the left, it's not the greatest values, I'm getting smaller and smaller values of h. So at this point here, where the wall literally just balances at this point here, this is my maximum value. Now for my maximum value of h, I can just use normal trigonometry. I know this total distance along here is 2a. This distance here is 30. So working out this height here is just going to be 2a times by sine 30. Sine 30 is going to be a half. A half times 2 is just going to be a. So my maximum height cannot be anything more than a. So that means I've got an inequality where h is less than or equal to a. Now, this is the inequality. This is the really important and the hard part to find. Once you've got h is less than or equal to a, you're away because we know the value of h is the answer we got for part B. So 11 over 24 times by 2d plus a is less than or equal to a, and this is your first mark. But noticing this part here is tricky. From here, we're just going to multiply by 24, divide by 11, take a away from both sides, leaving me with 13a over 11 is less than, 2d is less than or equal to 13a over 11. Divided by 2 gives me d is less than 13a over 22, and this is for your second mark. These were very tricky 2 marks in the exam, so give yourself a big tick if you managed to get them correct. Well done. The mark scheme on this question shows one method mark for getting the 11 over 24 times by a plus 2d is less than or equal to a. Explains over here about the condition for h cannot exceed the 2a sine 30, which is equivalent to a, and this is where your inequality is coming from. The second mark is your A2 mark for your answer for getting d is less than or equal to 13 over 22a, so that's the greatest possible value of d. Give yourself a big tick if you got that correct. Very, very tricky, so well done. They were 2 hard marks. We're now going to look at the last part, which is the easiest mark in this. It's only worth 1 mark and state 1 improvement. So it's 1 mark for 1 improvement. If it asked for 2 marks and it said 2 improvements, you'd have to give 2 reasons. There is lots of reasons that you can give. The easiest thing is to look at this word here, uniform. A ladder is probably not going to be uniform, so you could say that it may not be uniform. And this keyword here, smooth, we had a smooth surface up here, it's unlikely to be smooth as well. So they are 2 key reasons. The mark scheme says there is 1 mark for any of these reasons. So model the ladder as a non-uniform rod. Make sure that you include friction for the ladder and the wall. Consider the size of the object at part C. Consider the thickness of the ladder. Consider the fact that the ladder could bend. Any of these will give you 1 mark in the exam. If you suggest that the model is the ground as a smooth or for using more accurate value of G, you get 0 marks in this case. Often this is a way of getting a mark for saying a more accurate value than G. So that is a key way of getting a mark for normally, but in this case here, they're looking for these reasons over here. So make sure you give the correct reason. If you found this video useful, please share, like and subscribe so we can all get great at maths.